In this video, we are going to learn about different performance testing types, its terminology, and create our first load test using K6 and JavaScript. By the end of it, you'll have good enough understanding of the topic to be able to create your own performance tests. First, let's talk about performance testing definition. Performance testing is a practice aimed to discover how the system performs under certain conditions. Sorry about the tautology. What is the load testing then? Many people will be saying load when they actually mean performance. And the other way around. Wait, they're not the same? Not quite. You see, load testing is a subset of the performance testing. You apply a specific load to the system to test its behavior. What kind of load test types are there? There are many, here's a few. Stress or breakpoint tests to find at what load system will die. Normal load tests to just double check that when you ship something to production it's gonna work. Spike tests to mimic the sharp spike in requests, like DDoS or massive online sale. And endurance or a SOC test to see how system performs under load for a long period of time. Don't worry, we're gonna start writing code very soon. The last thing I want to explain here is scaling and recovery. Scaling aims to check that your system adds and removes instances as the load comes and goes. Recovery is to check how quickly system will heal if the load is removed. You can see that these circles overlap with the load one because they need a load in order to be tested, but the focus of them is slightly different. That's why I visualize them as a separate thing. Now it's time to write our first performance test using the load testing tool called K6. And don't worry, I'm gonna show you more pictures later in order to make everything very visual and simple. Let's Google K6 load and go to their website. Go to documentation, installation. I'm on Windows, so I need to run this command. For those who don't know what Choco is, Chocolate is the Windows package manager. If you type in your terminal Choco and it doesn't throw saying unknown command, it means you installed it correctly. After I run this command, and if I type K6 in my terminal, you can see that it gives me something. Again, it means that K6 has been installed correctly. Now when we have a tool installed, we need a test script to run it with this tool. Let's create a new JavaScript file. I'll call it load. And I'm going to have something very simple here. I'm going to use HTTP client from K6. And I'm going to just make a HTTP GET request to this URL. Be careful with the URL you use here. You don't really want to accidentally DDoS someone. This could be illegal. Only test services that you own or that allows it in their terms and conditions. Now we just need to run our script. As you could imagine, it should be something pretty simple. So let's try K6 run our script name. Big success! We just created our first performance test and let's have a closer look at the results. As you can see that there was no much load this test generated, it only made one HTTP request. Worry not, let's make this test more interesting. Let's add options and force it to run for 30 seconds. Options is just a configuration object K6 have. So here I added duration 30 seconds. Let's run it again and see if it's different. You can see that it's running and it's gonna run for 30 seconds and there's the progress. This is how many requests are being made. Now, if the previous results were confusing, these results will be definitely a little bit more overwhelming because there is more data here. You can see that this block is new and this block is new. The most important line here is this one, HTTP request duration. You can see that it has average, minimum, median, maximum, P90 and P95. What are they? What do they mean? Minimum and the maximum are trivial. But what is the difference between median and average? Imagine we've made 5 requests. 4 of them took around 100 milliseconds and one was a slow one, which took over 1 second. Average in this case will be sum of times for all requests divided by the amount of requests. In this case, it's around 300 milliseconds. Median is different and actually pretty simple. If you sort your requests in order from the slowest to the fastest, then the median is the request in the middle. In this case, it's 100 milliseconds. You could see that the average metric could shift the perception of how well system behaves, by quite a lot. You just need a few outliers and your picture of reality will change. This is why we also need percentiles or P90 and P95 metrics. Imagine we've made 100 requests. Some of them were slow, some of them were fast. Let's sort them from the slowest to the fastest. Now, if you look at the request number 90, you could see that it took 934 milliseconds. So this is our P90. It means 90% of the requests are faster than this time. Same with P95, means 95 requests are faster than 960. So if you look at this line again, you could see that 90% of the requests were faster than 196 milliseconds and 95% of the requests were faster than 198. Another thing that we didn't talk about is this line, VUs. VUs means virtual users. It's one of the fundamental bricks that we use to control load pattern. Let's modify our options, add some VUs and see if it changes how the test being run. If I run it right now, you can see that I have 5 VUs and you can see that I have 5 VUs here. So it means that now not only one user making HTTP requests to this endpoint, but 5 of them. If we look at the numbers again, you can see that we made quite a bit more iterations, which mean HTTP requests, because we had 5 users hitting it. But if you look at this line again, you could see that system performance was still pretty good. System didn't even sweat. I can judge by, let's say, median being not very far from P95. This means that our response line is flat, which is very good. So if I were doing real performance test, I would say, well, this load is not enough. I need to put more, and so on, and so on. Remember this picture? Let's try to visualize the blue circles. What kind of load patterns are they represent? On the vertical axis, we have the amount of load, and on the horizontal axis, we have time. First goes the normal load pattern. This is baseline. Usually it's a typical load that is generated by your users in production. Next is the breakpoint or stress test. You can see the load here is constantly growing. The goal here is to see where the system will choke and die. Next one is the endurance test. The goal here is to apply a little bit higher load than normal and run it over a longer period of time than you would run your performance test normally. And the last one is the spike test. You are being DDoSed? Are you doing Black Friday massive online sale? This is the load pattern your production will experience during this time. Now we know the theory and we're ready to learn another concept of case 6 called stages. Stages is something that allows you to fully control the load testing pattern. They are an instruction saying for how long and how many virtual users, or load basically, you apply. Let's add some stages to see it in practice. First, I'm gonna delete these two because I don't need them anymore. And now I add stages. Stages is just an array of objects and each object says for how long and how many virtual users is your target. So if you look at this picture, we are instructing case 6 to run for 10 seconds and ramp it up from 0 to 10 and then run it for 10 more seconds, staying on the 10 users. Let's run and see how it goes. So you can see VUs are growing. It's 3, 4, 5. And after 10 seconds, it's gonna be flatline 10. So now we're on the peak and we are flatlining on the 10 virtual users. If we get back to this picture, we just simulated normal load. We ramped up a little bit and then we stayed flat. With stages, you are able to manipulate both variables on this graph, load and time. So you could create these little legs or stages, say ramp up like that, ramp up like this, ramp down like that, stay flat. It gives you full flexibility and control over your load test experiment. And now you can do basic performance testing with case 6. If you are enjoying the content, don't forget to click like and subscribe, and also click on this video. You're gonna love it as well. See you next time.